Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to continue where I left off, drawing practice problems on how to do Lewis dot structures. Okay, so in my last video, in part one, I stopped at NH3, so I'm going to do the rest of these. So let's start with number 5 then. So we have oxygen O2. So again, the first step is to tally up or calculate the total number of valence electrons in O2. Since oxygen is in group 6, it has 6 valence electrons. I have 2 oxygens. Each of them have 6, so that's a total of 12. So I have 12 valence electrons for O2. So next step is to create my skeletal structure. Again, just like hydrogen, I only have 2 atoms, so I'm going to bond them together with one bond. So I have oxygen bonded to oxygen. So that's my skeletal structure. So I used one bond, so that's 2 electrons for this bond. So I'm going to subtract out the 2 from my total. So subtract out 2, and I've got 10 left. So 10 more valence electrons. So that's step 2. So step 2 is finished. Now step 3 says add lone pairs to your outer atoms. Well, since both of these are kind of bonded to each other, they're kind of both the central atom and the outer atom. So basically I'm going to give lone pairs to each of the oxygens. So what I want to do is I can make this one the central atom, and I can make this one the outer atom, and I can add lone pairs to this one. So I'll have 3 lone pairs there. So that's 6 electrons. Subtract that from the 10. So I subtract out 6, and that leaves 4 electrons left. So if this was my outer atom, then this is going to be my central atom. So step 4 says any electrons left over, add them to the central atom as lone pairs. So I'll add 2 lone pairs there. And so here I used up the 4 electrons. So 2 lone pairs, 4 electrons. So subtract the 4, and now I have 0 left over. So now step 5, I want to double check my Lewis dot structure here, make sure everyone's happy with an octet. This oxygen has 3 lone pairs. That's 6 electrons plus the bond, that's 2 electrons there. So this oxygen is happy with an octet. But notice that this oxygen only has 2 lone pairs and a bond. So 2 lone pairs, that's 4 electrons. The 2 electrons from the bond, that's 6. So this one is not happy with an octet. But I don't have any more electrons left over, so I can't add any more. So this is where we go to step 6, the last step. And that step says that if you have an atom or central atom that does not have an octet, then you have to move a lone pair from the outer atom to create a double bond. And so here, this is my outer atom. I'm going to take a lone pair and create a double bond until I can get an octet for the oxygen. So I create a double bond. And so the double bond is represented by 2 lines. So each line is a bond. And so now that this lone pair became a bond, I have 2 lone pairs left. So I put 2 lone pairs on my oxygen. This one has 2 lone pairs. And so now I can double check again to make sure everyone's happy with an octet. So here, this oxygen has 2 lone pairs, that's 4 electrons. 2 bonds, that's 2 electrons each, so that's 4 electrons. So 4 and 4 is 8. So this oxygen is happy with 8. And then this oxygen has the same thing, 2 lone pairs for 4 electrons and 2 bonds for another 4. So now this oxygen is happy with 8 electrons. So this is our Lewis dot structure for oxygen O2. Okay, What about N2? N2, same thing. So I have two nitrogens bonded together. So step one, figure out what the total number of valence electrons for the molecule is, since each nitrogen has 5 valence electrons because nitrogen is in group 5. So that's going to be a total of 10 valence electrons. So here I have 10 valence electrons for my nitrogen, N2. So then I have two atoms. So step two, create the skeletal structure, bond them together with one bond. So here I have my two nitrogens bonded together. So now this is my skeletal structure. So they're bonded together and I have one bond. So that's going to be 2 electrons. So I'm going to subtract those 2 electrons from, from the total. So 2 electrons, and that gives me 8 electrons left. So step 2 is done. Now step 3, add lone pairs to your outer atom to give it an octet. So since I only have 2 atoms, I'll say that this one here is the central atom, and then that would make this one the outer atom. So I'll add lone pairs to this atom of nitrogen to give it an octet. So here I'll have 3 lone pairs. So that's 6 electrons. So I'm going to subtract those 6 electrons from my total. So subtract 6 electrons, and I have 2 electrons left. So again, that's it for step 3. Now step 4, if you have electrons left, put those electrons on the central atom as lone pairs. I have 2 electrons left, so I'm going to put them on this nitrogen as a lone pair. So that's 1 lone pair. Subtract those out from the total, and I have 0 left. So now I have no more electrons to give. So now I look at my Lewis dot structure. I'm step 5 now, Lewis dot structure, make sure everything is good. So I'm looking for everyone being happy with an octet, unless of course you're an exception. So nitrogen is not an exception, it should have an octet. So I have 3 lone pairs, that's 6 electrons, plus the 2 in the bond that's being shared. So that's 8 for the nitrogen. And so look at this nitrogen here, I have 2 in the bond and 2 here. So, hold on a second. Sorry about that. So this nitrogen only has 4 electrons. So I need 4 more for an octet, and I have no more electrons to give. So I'm going to have to move electrons. So just as step 6 says, if you don't have any more electrons and your central atom doesn't have an octet, then you're going to have to move lone pairs from an outer atom to create double or triple bonds. So I need to move lone pairs from here until I can get this nitrogen an octet. So if I move this lone pair here, create a bond. So then I have nitrogen with a double bond. So now this one has 2 lone pairs, and this one still has 1. This nitrogen still has an octet with 2 lone pairs and 2 bonds. And now this nitrogen has a lone pair and 2 bonds. So that's 4 electrons from the 2 bonds. And I have 2 from the lone pair. That's 6. Still no octet. So I got to move another lone pair. So I'm going to take a lone pair from this nitrogen again, create another bond. And so now I have a triple bond between the nitrogens, and this one has 1 lone pair, and this one has 1 lone pair. And so now if I double check, this nitrogen has 1 lone pair, 2 electrons, 3 bonds. Each bond is 2 electrons, so that's a total of 6 electrons. 6 plus 2 is 8. This one is good. And now this one has the same pattern. 1 lone pair, 3 bonds, that's 8. So now both atoms are happy with an octet. So this is the final Lewis dot structure. So this would be Lewis dot structure for N2. Okay, what about CO2, carbon dioxide? So carbon dioxide. So first step, add up all the valence electrons in your molecule. So we have 4 electrons for the carbon. So carbon has 4 valence electrons, and I have 2 oxygen. Each oxygen has 6 valence electrons. 6 because it's in group 6. Carbon has 4 because it's in group 4. So I have 2 oxygens. Each one has 6 electrons. That's 12. So oxygen, that's going to be 2 times 6 is 12. And so add those together, and I have 12 plus 4 is 16 total valence electrons. So I have 16 valence electrons to work with my carbon dioxide molecule. Okay, so that's step 1. Step 2, set up the skeletal structure. So remember, least electronegative atom is the central atom. Carbon is less electronegative than oxygen. It's also written first, which is usually the atom that's the central atom. So carbon is going to be my central atom. So I have carbon, and I'm going to bond the oxygens to the carbon. And that's my skeletal structure. So I'm bonding everything once. So I used 2 bonds, 2 electrons for each bond. So that's 4 electrons that I used. So I'm going to subtract that out from my total. So that leaves 12 electrons left. Okay, so that's step 2. Step 3, add your lone pairs. Add lone pairs to the outer atoms in order to give them an octet. Okay, so I'm going to add lone pairs to the oxygen. So that's 1, 2, 3. So that has an octet. And this is 1, 2, 3. So I have an octet here. So I used 6 electrons here, 6 electrons there. That's a total of 12 electrons. So I'm going to subtract out 12 because I used them. And now I have 0 electrons left. So at this point, I don't have any more electrons, so I have to skip the next step. Remember, the next step, step number 4, is if you have electrons left over, add them to your central atom. I don't have any left over, so I can't add anything to my central atom. So step 5, double check to make sure everyone's happy with an octet unless you're an exception. So my oxygens are happy with an octet, so I have 3 lone pairs, that's 6, plus 2 in the bond, that's 8. I have 3 lone pairs, that's 6, plus 2 in the bond, that's 8. But look at my carbon. My carbon only has 2 bonds, so that's 2 electrons, 2 electrons. So carbon only has 4 electrons. 8 is what carbon wants. So we got to go to step 6. Step 6 says, again, if your central atom doesn't have an octet, then you need to move lone pairs from your oxygens to create bonds, double bonds, triple bonds, in order for carbon to have an octet. Now, there's a couple of ways you can do this. You can either take 2 lone pairs from one oxygen and create a triple bond, and that would give carbon the octet, right? So you can move these 2 electrons here and create a triple bond with the carbon, and just leave this one with the single bond and 3 lone pairs. And so the carbon now has an octet. Everyone's happy with an octet, so this is okay. But this isn't the best one because we want to have symmetry. So if symmetry is possible, then symmetry is the way to go. So there is another way you can use formal charges to figure this out, but I'm not going to go over formal charges in this video. In a previous video, I went over formal charges and how to do that. So you can check that video out, but I'm not going to go over this. So here, I'm not going to go over formal charges in this video, but what I will kind of point out is this idea of symmetry. So rather than having this is okay, But a better way to go about is to, instead of moving both lone pairs from one oxygen, you can move one lone pair from each oxygen and create double bonds on each side. So then you get oxygen with two lone pairs and a double bond there. And then you got a double bond to this oxygen with two lone pairs. And so this would be a better Lewis dot structure. One other thing you keep in mind is remember the honk 1, 2, 3, 4 rule, right? So honk H is one bond, oxygen loves to have two bonds, and so on. So carbon loves to have four bonds. So here you'll see that carbon has four bonds, but you'll see that each oxygen has two bonds, which fits the pattern. So this one is a better one based on that rule as well. Okay, so this is the Lewis dot structure for carbon dioxide. What about HCN? So nitric acid, or I'm sorry, cyanic acid, hydrocyanic acid. So we'll erase some of these, get these out of the way to make room for the others. So again, HCN. So first step, add up all the electrons, the valence electrons from all the atoms to get the total. So hydrogen has one valence electron, so hydrogen has one. Carbon is in group 4, so it has 4 valence electrons. And nitrogen is in group 5, so it has 5 valence electrons. So nitrogen has 5. Add these together, you get 10 total valence electrons. Step 1 is done. Step 2, put it together as a skeletal structure. So remember, here hydrogen is written first. Normally the first atom is the lesser electronegative one. It's the central atom, but hydrogen, as we know, only bonds once, so it cannot be a central atom. Carbon is the next lesser electronegative atom, so carbon would be the central atom, not nitrogen. Nitrogen is more electronegative. So we're going to use carbon as our central atom, so carbon, and then we're going to bond nitrogen and hydrogen. So both hydrogen and nitrogen are bonded to the carbon. So this is step 2. So we used 2 bonds, so that's 2 electrons per bond, so that's a total of 4. So we're going to subtract out 4 electrons, and that gives us 6 electrons left to use. So step 3 says put lone pairs on the outer atoms in order to make sure that they have an octet, if possible. So hydrogen is fine with 1 bond, so we're not going to put lone pairs there. But look at nitrogen. Nitrogen would love to have lone pairs. I have 6 electrons, so I can put 3 lone pairs on the nitrogen. So I used up all 6. I have 0 left. So at this point, I can't put lone pairs on my central atom because I don't have any more left. So I need to look at my Lewis dot structure to make sure everyone's fine. And right away, you'll see that everyone's fine. Hydrogen has 1 bond. Nitrogen has 1 bond. That's 2 electrons plus the 6 electrons here. So that's 8. So nitrogen has an octet. Great. But as you can see, carbon only has 2 bonds. So that's 4 electrons, 2 for each bond. But it needs 4 more. So we're going to step 6. Step 6, we need to move lone pairs from our outer atoms to create double and triple bonds. So since carbon needs 4 more electrons, we're going to have to move 2 lone pairs to create triple bond. So this lone pair and this lone pair will move to create a triple bond. So we'll get H bonded to carbon with a triple bond with nitrogen, and we have the lone pair left over. And so now everyone's happy. Hydrogen has 2 electrons. It's happy with 1 bond. Carbon now has 4 bonds. So that's an octet. 2 electrons in each bond. So that's 8 electrons. And nitrogen is happy with three bonds in one lone pair. So that's going to be 8 there. So this is the Lewis dot structure for HCN. Okay, next, what about Cn minus? It's a polyatomic ion. So first thing we need to do is calculate the total number of valence electrons. So carbon has 4 valence electrons. So we'll add that together. So we have 4 valence electrons for carbon. And nitrogen has 5 valence electrons. So we have 5 valence electrons for nitrogen because nitrogen is in group 5. Carbon has 4 because it's in group 4. But we're not done yet. We have a charge there. Remember, we have to take in consideration the charge. If you have a negative charge, you have to add that to your total. If you have a positive charge, you got to subtract that from your total. So -1, we have a -1. That means we have one more electron. Electrons are negative. So a -1 means we have one more electron. So we're going to add one more electron from the -1 charge. So we have a -1 charge, so we're going to add an electron. So that means we have total of 10 electrons. Okay, so now that we know the total, we're going to bond our atoms together. There's only 2 atoms, so it's really easy. That's going to be C bonded to N. Okay, so in this case, carbon is our central atom because carbon is the lesser electronegative atom. So here, nitrogen is going to be our outer atom. So we're going to add lone pairs to the outer atom to give it an octet. But first, we need to subtract out the 2 electrons that we have from our bond because we use those already. So we're going to subtract out 2 electrons, and we have 8 electrons left. So now we're going to put lone pairs onto the nitrogen, which is our outer atom. So we're going to put lone pairs, give nitrogen an octet. Nitrogen now has an octet. So 6 electrons plus 2 in the bond, that's 8. So we have to subtract out the 6 we used for the lone pair. So subtract out 6 electrons. We have 2 electrons left. Step 4 says that if you have electrons left over, you add them to the central atom. In this case, carbon. So we have a lone pair there. We used up our last, so subtract out those 2. And we have 0 left. So now we look at our Lewis structure to see if everything's okay. We see that nitrogen is fine. It has an octet. But carbon has a lone pair, which is 2 electrons, and it has a bond, which is 2 electrons. So it has 4 electrons. It needs 4 more. So we got to go to step 6. Step 6 says we got to move electrons, lone pairs, to create bonds in order to give the central atom the more electrons. So since we need 4 more electrons for our carbon, we're going to have to move 2 lone pairs to create a triple bond again. So we have to move these 2, and so we get carbon, triple bond to nitrogen. Both of them are going to have a lone pair. Since this is an ion, we got to put brackets around it with the negative charge. And so here's our Lewis dot structure for Cn minus. And so you can see that both of them are happy with an octet. And so this is the Lewis dot structure for Cn minus. Okay, what about the last 2? We have CH3OH next. So let's go ahead and work on that one. So this is another example of an organic molecule. So one of the things you got to keep in mind for organic molecules is how they're connected, and the formula kind of tells you how they're connected. So whenever you have a carbon, whatever follows the carbon is bonded to that carbon. So think about that. So hydrogens, these 3 hydrogens are bonded to that carbon because they follow the carbon. Now, the oxygen follows the hydrogen, but remember, these hydrogens are bonded to the carbon, and hydrogens only bond once. So this oxygen can't be bonded to the hydrogen. So this oxygen is also going to be bonded to that carbon. And so this hydrogen here follows the oxygen. So that hydrogen is bonded to that oxygen. So that tells us what our skeletal structure is. Okay. So with that in mind, let's go ahead and do this. So first step is always add up the valence electrons. So I have one carbon. So the one carbon has 4 electrons. I have 4 hydrogens. Each hydrogen has 1 valence electron. So I have 1 electron. I have 4 hydrogens. So 1 times 4 is 4. So I have 4 valence electrons for my hydrogens or from my hydrogens. And I have 1 oxygen that has 6 valence electrons because it's in group 6. So oxygen has 6 valence electrons. So if I add these together, 4 plus 4 is 8. 8 plus 6 is 14. So I have 14 valence electrons. So that's the total number of valence electrons. So now I put my skeletal structure together and I read the formula. So I have my carbon, the 3 hydrogens, whatever follows the carbon bonds to the carbon. So the hydrogens, these 3 hydrogens are bonded to the carbon. So 1, 2, 3. So I put the hydrogens bonded to that carbon. Now the oxygen can't be bonded to the hydrogen because these hydrogens are already bonded once and hydrogen only bonds once. So this oxygen has to be bonded to the carbon. And then this hydrogen follows the oxygen, so it's bonded to the oxygen, like that. So there's my skeletal structure for this formula. So that's step 2. Now I have to subtract out the number of electrons from each bond. So I have 1, 2, 3, 4, 5 bonds. That's 2 electrons per bond. That's a total of 10. So I'm going to subtract out 10 electrons, and that gives me 4 electrons left. So step 3 says add the valence, add lone pairs to your outer atoms. Well, if you look here, hydrogen is my outer atoms for these. Hydrogen only bonds once. I'm not going to give them lone pairs. Carbon is the lesser electronegative. So oxygen is kind of like an outer atom. So if I look at this as my central atom, this is an outer atom. So I can give oxygen here lone pairs. So I'm going to add 2 lone pairs. I'm going to give it an octet. So it needs 4 more. So I give 2 lone pairs, and I have 4 here. So I just use those up. So I'm going to subtract those out. So I have 0 left. So now that I have no valence electrons left over, so I can't do anything now. So now I look at my Lewis dot structure to make sure everyone's happy. So hydrogen is happy with 1 bond, so I don't need to do anything there. Carbon has 4 bonds, that's 8 electrons. That's good. And the oxygen has 2 bonds and 2 lone pairs, that's 8. So that has an octet. Everyone's happy. This is the Lewis dot structure for this molecule. And again, you can see that it follows the honk 1, 2, 3, 4 rule, right? Hydrogen bonds once, carbon bonds 4 times, right? So we got 4 times. And oxygen bonds twice and has 2 lone pairs. So oxygen likes to have 2 bonds. So this is a good Lewis dot structure. Now, finally, what about this one, CH2O? Let's do this one really quickly. So here, again, I have carbon. Carbon has 4 valence electrons. I have 2 hydrogens, that's 2 valence electrons total. And I have oxygen, that's 6 valence electrons. So that's going to be 12 valence electrons. I'm going to put my molecule together. The hydrogen here follows the oxygen. So the carbon, follows the carbon. So the hydrogens are going to be bonded to the carbon directly. Okay, so then where's the oxygen going to bond? Well, it's not going to bond to the hydrogen, it's going to bond to the carbon. So I'm going to have 1 bond there. So that's my skeletal structure. Okay, so I'm going to stop here. I'm going to finish up in my next video. Thanks for joining me. Please make sure you like this video, subscribe to my channel, hit that notification bell, and add a comment to the comment section. Thanks for joining me. Have a great day.